So the next least code question is Fibonacci number 509, which is another easy dynamic programming question. So what we need to do is follow the famous Fibonacci numbers sequence and return the end result after n steps. So as the question tells us, we will get in the input a number n, which is an integer, and we will calculate the f of that number. So we will start off by doing a simple dynamic programming solution. We will do starting with the edge cases. For example, if we got n is equal to 0, if n is 0, we return 0, right? Now if n is equal to 1, just return 1. But what we will do is we'll do dp of, we'll define our dynamic programming array, which is going to be the size of n plus 1, right? So we've got it's going to be 0, all the cases, times n plus 1. Okay, now we will update the values. For example, we've got 1, the first value we've got is going to be 1, dp of 2 is also going to be 1, and now we'll update the other values in order to calculate the final n value. So it's going to be f for I in range of n, dp of I is equal to dp of I minus 1 plus dp of I minus 2, right? But this is actually starting from the third value and going to n plus 1, because n plus 1 is not included in the loop. So this will calculate dp of n that we will be returning. So return dp of n, edge cases, run, and submit. So we've got a very fast solution. It's the memory is not bad, but we can still avoid using dynamic programming, since here we're only using the previous two values. Because I mean, this is the question here. If we look at, for example, if we start with one step, so we got 1. Following the Fibonacci sequence, we do 1 plus 1 is equal to 2. We add a new 1 and a new 1 here. And then we do the same thing, 1, and then we add 1 with 2. So we get 3. And so on. We got 1, 4, this time 6, 4, and 1. Right? But at each step of the way, we only use the previous two values. So these two are used to calculate this one. These two are used to calculate this one, and so on. So there isn't actually a real need to use dynamic programming. What we can do is define 3 variables. The first one is going to be first 1. Second one is going to be 1 also. And for I in range 3n plus 1, we'll define a third variable, which is just the sum of the second. Let me start with the first plus the first. So second was first, and then we update the previous values. So we got the first is going to be the second, and the second is actually now the third. And since in the last step of our loop, we'll have the second equals to the third, we can just return second. Let me run this and then submit it. I mean, it was supposed to be so much better in terms of memory utilization. Now it's, I mean, it's not very exact. Sometimes, I guess it depends on when do you run it, I think. Yeah, it's not fixed, neither the runtime or the memory. But this is supposed to be the most optimized solution. No need to use a DP array.